The universe is vast. By comparison, the Earth in all its glory is less than a grain of sand. To think that in all of this, there only exists one single beautiful planet that contains a collection of intelligent species. Perhaps the purpose of humanity is to seed the universe and spread the gift of life throughout the cosmos. How long before such a Herculean task is actually achievable? Let's explore. This is Why Engineering. For a period of time in your life, there is most likely to have been a time where you gazed at the magical, almost spellbinding night sky littered with tiny stars and wondered, is anyone out there? How, in the scale of all this majesty, is there nobody else? Perhaps we are the firstborn, a reference and catalyst where life blooms, begins to spread throughout the universe, and becomes a concoction of intellectual beings as far as the eye can see. We have already long since started to push the boundaries of our planet and encroach upon the inky blackness of space in search of a new frontier. It will come as no surprise that this is no easy task. Everyone in space wants to kill you. But if there's anything we could be proud of as a human race, it's our persistence to explore, to challenge the impossible, to go anywhere that nature tells us we have no right to be. And through these harsh and unforgiving environments, innovation and human ingenuity shines brightly. As with any journey, there must be a starting point, and that is where we are now. The International Space Station is a magnificent, colossal feat of engineering, travelling in a permanent state of freefall, 15,500 miles above our planet. It is the culmination of thousands of human efforts, in solidarity, from around the globe. It transcends boundaries, rivalries, and conflict. If we were to pick the greatest man-made structure, surely this would be high atop the list. A great number of technologies and efforts are in concert to make this happen. If you were to muse upon the idea, rockets are kind of an insane idea. A large amount of explosive matter contained in a ridiculously massive metal tube. None of that ever sounded like a good idea. And yet, astronauts spend years of their life training to ride such a thing. The route to safe space travel has been littered with loss and tragedy, but due to their courage and sacrifice, the technology has become synonymous with reliability, redundancy, and safety. At this moment in time, it is the only technology that is readily able to provide access to space. Reusable rockets is not something you would normally expect to be possible, until SpaceX shocked the world and delivered. This is the first significant enabler in the viability of space colonization. Turns out that leaving Earth is quite a difficult task. A craft has to reach the speed of 25,020 miles per hour in order to escape the gravity influence of this planet. Adding more fuel is not the solution, as there becomes a point where the weight of that fuel is more significant than the thrust it produces. SpaceX, however, proposes a different idea. If there were fuel production facilities on the moon or refueling in space, it would unlock the ability to go further than the immediate vicinity of this planet. It means that constraints on mission requirements to accommodate the weight of the fuel for a return trip is no longer something that needs to be considered. It is unreasonable to assume that government entities alone will get us a permanent settlement in space, at least in any time frame where the majority of us will still be alive, so commercial interest is key. Thankfully, the universe offers the carrot for the donkey of the corporate world. Enter asteroids. 16 Psyche, for example, is valued at $700 quintillion. That's a 7 with this many zeros. That should be enough of a juicy carrot to catch interest, don't you think? The 2015 US Space Act, that allows companies to own the materials they mine in space, produced a barrage of companies, born from the allure of all that precious metal resource. It will not be long before asteroid mining becomes a very profitable industry. That is not the only commercial venture or industry that is on the horizon. space tourism is the new hot topic of late. Behold the Gateway. This structure was dreamed up by a company called the Gateway Space Foundation. It will be humanity's first space hotel, which will spin at 1G to provide artificial gravity for its inhabitants. Check out their YouTube for the numerous technical details and plans for them to make this happen by the lofty goal of 2025. A question to you viewers though, what would make you consider living or working in space? Do you think this is a waste of time and resources? Let's discuss in the comments. Obviously, we cannot live in space without air, sustenance, or some kind of protection. We already know how to convert urine into clean water, scrub CO2 build-up from the air, grow plants, produce electricity, and more. While there is much room for improvement, the technology to occupy space has been regularly used for 20 years aboard the ISS. There are two wealthy, well-known visionaries with different plans to colonize space: Elon Musk and Jeff Bezos. Elon's vision is to colonize Mars with space habitats, tunnels, and solar farms that, with some chemical wizardry, produced rocket fuel and water. Jeff has plans to produce a megastructure in space, called a ring world, that because of the sheer size and scale, produces its own weather and gravity. It may seem that these grand visions are entirely impossible, but I can assure you, they are well on the way to becoming reality. When humanity begins to think this big, what is there not to be excited about? What a time to be alive. The universe itself is giving us a helping hand, with the water ice deposits on the moon and even on Mars. I hinted at the capability to produce power on other planets. Whether that solution is solar panels or compact nuclear reactors, this energy needs to be stored. Hydrogen fuel cells are the ones with the highest specific energy, most commonly used for space applications. Surprisingly, habitat designs for Mars, lunar orbit, and the moon are already well into development. Bigelow Aerospace, Lockheed Martin, and Boeing, just a few of the notable mentions. But who exactly is going to build those structures in that deadly and inhospitable environment? It is more than a little difficult for us to do as a human right now. Autonomous robots are the answer, ones that utilize 3D printing to construct and build an environment that's safe for humans to use. They must ideally use the material available on that celestial body, or if it's not possible, brought from Earth. The engineers over at the company AI Space Factory won a NASA-sponsored competition to do just that. This is one of the reasons why I'm proud to be an engineer. We are the inventors, problem solvers, the people responsible for making this world turn smoothly upon its axis. Albert Einstein said it best. In summary, we've had a briefing on some of the items created and developed that will get us into space. Habitats, refueling, asteroid mining, reusable rockets, autonomous robots, energy storage and infrastructure. This is only the beginning, a viewing port into what has already been suggested and tested. Wait until you hear about what's in store on the next leg of the journey with Y Engineering. Thanks for the view and have a beautiful rest of the week. Thankfully, the universe carrot. The almighty universe carrot